Okay, last one. And this one involves a less trivial rational function. We had the one from before that was, fairly simple. Remember this, g of x, 1 over x minus 1. It's rational, I guess, but it's rational paired with a linear. What's this one? Rational paired with a linear again? Yeah, I was afraid of that. If I was a better person, then I'd be giving you a rational paired with another rational, because that's when sort of the fun stuff starts. You'll see one of those before we get to our assessment. At least you better, because you're going to be expected to handle a rational with a rational. But for right now, let's just go ahead and continue practicing with the slightly simpler situation. We're going to do the sum. And again, as you guys already know, the domain of f is going to be all reals because it's linear. The domain of g is going to be all reals, but not the number 4. So even before we do any work for the sum, we already know that its domain is going to be the intersection of those two domains, which is R, without a 4. We already know that's our domain. May as well write it down. Now, as far as the algebra, as far as simplifying everything, you're going to get the 3x plus 1. May as well put it over 1 now, because you know you're adding to it a fraction. And you know you're going to need that common denominator. So we've got our little 1 as a placeholder. Needs to get multiplied by x minus 4. The numerator needs to get multiplied by x minus 4 also. And technically, the numerator should be in parentheses so that we remember to FOIL everything out nicely. So let's see what this turns into. It's going to be 3x squared minus 12x's plus an x, so minus 11x's, and then minus 4. And then we've got the other one too. You can technically just skip ahead and say, now I'm adding on the 2x plus 5. And you know that the whole rigmarole is just going to be over x minus 4. So simplify, you've got linear term. So add them up, you get negative 9. So we got 3x squared minus 9x. Then we've got a constant and a constant. And negative 4 and 5 makes 1 plus 1. And this will be all over x minus 4. So somewhat disappointingly, that's our final answer. We can already see that domain restriction of 4. We would have picked that up easily. The numerator is not factorable because 3 times 1 is 3, and there's no factors of 3 that give 9. So pretty simple math, pretty simple domain. Moving on. All right, so we're doing the quotient function. And these are tricky with rationals, but maybe you're catching on, so maybe less tricky. But we're going to put the rational function in the numerator, g, so 2x plus 5, over x minus 4, over f of x, 3x plus 1. Again, I would walk you through this by saying, just chuck this over 1, multiply it by its own reciprocal. That's going to get it to cancel right out. But whatever you do to the bottom, you got to do to the top. And so maybe you guys are starting to see that really what happens here is we're basically just getting the numerator multiplied by the reciprocal of the denominator. So you're going to keep that 2x plus 5 in the numerator. And your denominator, we're not going to expand this, remember. So your denominator is just going to be those two factors left in their factored form. So x minus 4 and 3x plus 1. Okay, so the good news here is we are seeing another semi-interesting domain. It was obvious to everybody that we couldn't have 4 in our domain because 4 caused g to be undefined right away. But now looking at our resulting function, we see that not only is 4 bad, but negative 1/3 is also bad. So we do have two restrictions again, negative 1/3 and also 4. And that 4 looks too much like a 9. Okay, that doesn't seem bad to me. Hopefully it doesn't seem bad to you either. Alright, now the difference function, we're going to go 3x plus 1. Subtract from it 2x and 5 all over x minus 4. We're going to check that over 1. We're going to get that common denominator. Put parentheses on that too. That means our numerator is going to be 3x squared. Minus 12 plus 1 is still negative 11x. And negative 4 times 1 is still minus 4. We're now subtracting this whole thing, 2x plus 5. And that's all going to be the numerator of a fraction whose denominator is the x minus 4. So combining like terms, you're going to land on taking away 2x from the negative 11x. So you'll have 3x squared minus 13x. Then you've got minus 4 minus 5, so minus 9. And it's going to be all over x minus 4. And my heart tells me that numerator cannot be factored. But let's just exhaust every avenue. We're going to go 3 times negative 9 for negative 27. That means we've got a 1 and a negative 27. That's not doing it. 3 and a 9. I think that's literally it, right? All of our factors are just 3s. 3, 3, 3. So either 1 and 20. Yeah, that's it. Those are the only options, and none of them are given 13. So we know we can safely say that we are just not factorable. And that means that our only domain restriction is still going to be just the 4 from g of x. So there's C. C has this function, this domain. Let's go to D. It's another quotient. This time the numerator is 3x plus 1. Again, I love me my placeholders, so I'd go over 1, then I would do the other fraction on the bottom, 2x plus 5 over x minus 4. And again, real quick, we're multiplying by the reciprocal. X minus 4 over 2x plus 5. I'd actually like to think that by now this is so robotic that you're just killing this off right away. That's gone. And the reason why we're multiplying by the reciprocal in the numerator is because that's what we did in the denominator. So now what? I said don't distribute, so just leave your numerator as 3x plus 1 times x minus 4. And leave your denominator as 2x plus 5. And then marvel at how your domain is nothing more than all real numbers except for, well, the denominator here could be 0 when x is negative 5 over 2. So we're going to have to eliminate that. But don't forget, we also need to make sure of what? We also need to make sure that g is never undefined. So that restriction at 4 still pervades. We still need to eliminate that from our domain as well. So we're getting rid of the negative 5 halves because our denominator would be 0 here if we didn't. In the quotient function, sort of our third resulting function, a function that, for lack of a better name, could be called h of x. Negative 5 halves is bad because it makes the denominator of h of x equal to 0. But we also have a function called g, who's got a denominator, and it equals 0 when x is 4. So 4 needs to be restricted too. But technically, we've got a third function, f, in our numerator, and any restrictions it doesn't have any. It doesn't have any restrictions. But you can imagine that if it did, you'd have to cut them out of your domain as well. So there. Again, I hope this is helping. Product. Let's not fake that the product is going to be hard. We're going to multiply this thing by this thing. So we're going to get this thing times the numerator all over the denominator. It's going to be 3x plus 1 multiplied by 2x plus 5. The denominator is going to be x minus 4. And that's it. So what's our domain, you might say? And you'd certainly say 4 still seems bad. And you'd be right. And there's nothing else to worry about, because we said any values of x that make the numerator equal to 0, they're not discontinuities, they're not removed from our domain, they're just the x-intercepts. They're fine. So that's it. We've got all of our restrictions for e. And now we're back to function composition. We've got 2 more to go. We're going to cram g into f, which means the outer shell is 3x plus 1, with the rational function getting jammed in here, 2x plus 5, all over x minus 4. Okay, so first things first, we can just distribute in the 3. Notice the 3 is only going to distribute into the numerator, because again, placeholder, put it as 3 over 1, and you're multiplying tops with tops and bottoms by bottoms, so the denominator is getting multiplied by 1. So it's going to stay x minus 4. Numerator is getting multiplied by 3 though, so it's going to become 6x plus 15. And that thing that looks like a 9 is a 4. Alright, then we're adding to that the number 1, but we need to rewrite the 1 as x minus 4 over x minus 4. So that we have our common denominator. Again, we're achieving that by expressing it as 1 over 1, then multiplying by x minus 4 over x minus 4. And we, of course, get x minus 4 over x minus 4. So we're at our final answer. 6x plus another x is 7x. And 15 take away 4 is plus 11. There's your numerator. Your denominator is x minus 4. There's your function. It seems pretty clear that our domain is still going to be all reals, but definitely not 4. Are there any other restrictions we need? Let's see. The inner function just didn't want there to be a 4. And the outer function doesn't care. So there's no new restrictions we need besides the 4. So again, kind of anticlimactic. And even when we go the other way around, when g becomes our outer shell, well, the algebra is going to be a little tougher. We're going to get 2 times some stuff plus 5 all over some stuff minus 4. Where the stuff is this entire linear function, 3x plus 1. So this can be cleaned up. If we distribute, we get 6x plus 2, which plus 5 is 6x plus 7. And in the denominator, you're just taking away the 4, so you get 3x minus 3. I am the kind of man that would be petty enough to be mad that you didn't factor out a 3. That's the best we can do. So what about that domain? Well, I can pretty clearly see that 1 is going to wreak havoc if we allow 1 to be plugged in. So surely we can't do that. No 1s. Are there any other restrictions though? Nope. because our inner function is, again, function f, which has no restrictions, so there's no reason to restrict anybody else. Any other value can be plugged in here and we'll be fine. Right. Yes. Right? Yeah, right. All right, moving on. Moving on to nothing. We're done. Whole homework assignment. And it only took us 20 minutes 4 times. So 80 minutes. Okay, it shouldn't have taken that long. But you guys weren't stopping to explain every little bit and do a couple extra problems along the way. So it shouldn't have taken you quite that long. But hopefully you took the time to watch along with me and pick up some of these pointers. Anyway, if you did watch, thanks. And if you didn't watch, you can't hear me right now anyway because you didn't watch. But you're a bad kid. All right, I'll see ya. Bye.